Alright, so today we're going to talk about ions. If you remember, last lesson was about atomic number and atomic mass, and today we're going to talk about ions. Ions are basically charged atoms. Because if you remember, up until now we've been talking about electrically neutral atoms. So an electrically neutral atom has the same number of protons and electrons, and we talked about that a lot because you need the same number of positive and negative charges to make a neutral atom. So if we have a neutral atom of carbon, remember the atomic number right here, 6, is always the number of protons in that element, in an atom of that element. And if we have an electrically neutral atom of carbon, there's no charge. The number of positive charges and the number of negative charges must be the same. So if we have 6 protons, 6 positive charges, we also must have 6 electrons or 6 negative charges. So that's what we talked about last time. This time we're talking about ions, and ions are atoms with a charge, and they gain that charge by either gaining or losing an electron. So we have ions basically just atoms with a charge. With a charge. And then they do that by either gaining or losing electrons. And so if they gain an electron, right, if they gain a negative charge, electrons are negatively charged, we call it an anion. So an anion would be an atom that has gained an electron and is now negatively charged. And let's put a negative ion. And then a cation, a positive ion. And that would be if a atom loses an electron, right? Because if, for example, if we had carbon here and for some reason if we had, well, we'll go over an example in a second, but let's say we had potassium here with 19 protons. If it was neutral, it would have 19 electrons. And then imagine if it lost an electron, then it would only have 18 electrons, so we'd have 19 positive charges because of 19 protons. And now if it only has 18 negative charges because it lost one electron, you can see it would be a positive ion, right? There'd be more positive, there'd be one more positive charge than negative charges, so then it would be called a cation. Now if we look at different elements, we can see that some of them are more likely to gain electrons and some of them are more likely to lose electrons. So some of them are more likely to become anions by gaining an electron, some of them are more likely to become cations by losing an electron. So let's add to our definition here. An anion is a negative ion, gains electrons. Remember, E negative is just abbreviation for electrons, and then a cation will be we lose electrons. And if we look at the periodic table here, the elements that will generally lose electrons to become cations are these over here on the left hand side, especially these in the first 2 columns. And the ones that will gain electrons to become anions are generally these kind of 2 columns. So not the farthest column, but the column starting with fluorine and oxygen. These columns will they'll generally gain electrons to become anions. Now let's see why that is. So let's take like lithium for example here. 3, atomic number 3, lithium. So lithium, if it has atomic number 3, let's draw out the structure here. We know it has 3 protons. So if it's a neutral atom, then we know it has 3 electrons also, so we'll draw that. So here's 1, Here's 2, here's the dot on the I. So remember there's 2 in the first shell, and then if we draw the next shell in lithium, we need 1 more electron here. So there we go. This would be an electrically neutral atom of lithium. So when it becomes an ion, remember we said the ones on the left-hand side of the periodic table will tend to lose electrons. Because remember, they want a full outer shell. And for this outer shell here of lithium to become full, it would need 7 more. It would need 8 electrons. And it only has 1 right now. It would be much easier to get rid of that 1 electron instead of gaining 7. Because if we get rid of this 1 electron, then this shell's gone. There's no more shell here. Then we just have this inner shell, and there's 2. And remember, the first shell, there's only 2, so this would be a full outer shell after we get rid of this electron. So this electron will go away. And then we end up with lithium. It would be like this. So then its outer shell would just have these 2 electrons. And then that would be lithium. It lost an electron. So now there's 3 protons in the nucleus still. And only 2 electrons outside. So it would be plus, right? There's 1 more positive charge than negative charge. Now if we look at the elements on the right-hand side of the periodic table, not these are the noble gases, those have a full outer shell already, they're very stable. But these 2 here, these will tend to gain electrons. So let's look at fluorine, atomic number 9. So if we have fluorine here, atomic number 9, if it's electrically neutral, means we have always 9 protons, and then we have 9 electrons, so we'll draw those out. So there's 2 in the first shell. Then in the next shell we need 8. So we need 8 for a full shell. We need 9 total for electrically neutral. So we have 2, so we need 7 more. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we look here, how many do we have in the outer shell? 1, 2, 3, 4, 5, 6, 7. We only need 1 more in the to make a full outer shell, and fluorine really wants that full outer shell. So it's much easier to gain 1 than it would be to lose all 7 of those and have this shell as being full. So many times we have an electron here, it will gain an electron, so it'll have an extra electron. Now fluorine would be, I'm not going to draw the shell again like I did here, I think you guys understand. This electron is joining this outer shell, so now we have 1 more negative charge than positive charge, so we have fluorine would have a slight negative charge. It would be an anion, right? It gained an electron. Now sometimes with some elements, they can gain or lose more than just 1 electron. And so if we go back to our periodic table here, generally, this first column here, they'll lose 1 electron because they're very similar to this. They just have 1 in their outer shell, all these elements. This second row here, they have 2 in their outermost shell. So if we look at, let's look at beryllium, Be, and here this has atomic number 4. So we know we have 4 protons. If it's electrically neutral, then we have 4 electrons. So we'll draw the electrically neutral version here. Oop, that's not a very good shell. 1, 2. So now we have 1, 2, 3, 4 electrons. So it's electrically neutral. Now this could either lose 2 electrons to have the full, then this would be the full outer shell here with just 2, or it would have to gain 6 to have a full outer shell of 8. So it's much easier to lose those 2. So we lose these 2 electrons, and now we just have Be, and now we just have these 2 left over. So it's happy. It has a full outer shell now. Remember, the most inner shell only holds 2, so it's really happy now. And then we lost 2 electrons though. So we'd write that as Be 2 plus, because it has 2 more protons than it does electrons now. And you can do the same thing over here on the right side. So these all have 7 in their outer shell. If you go in to this column here, starting with oxygen, those all have 6 in their outer shell. So they need to gain 2 electrons to be 8, and so they'll be these will generally, starting with oxygen, these will gain 2 electrons. So one last thing I want to mention in this video, and I'm going over, I try to stay at 10 minutes or under, but one last thing here are polyatomic ions. Polyatomic ions, your lesson mentions. So these are polyatomic ions. Polyatomic ions are ions that have more than one atom. They act like one ion together, but they're made from more than one atom. So examples, we have CO3, 2 minus, or we could have like NH4 plus. Right, so this CO3, that's actually 1, 2, 3, 4. That's 4 atoms. This is a molecule. It's 4 atoms bonded together. But overall, it has a -2 charge. So this molecule acts overall as a -2 charge. Same thing, NH4, that's actually 5 atoms, right? 1 nitrogen, 4 hydrogens, that's 5 atoms. But overall, they act as a +1, a 1 positive charge. So that's what polyatomic means. Poly means, the suffix here means more than one. Polyatomic, more than one atomic atoms. So polyatomic, more than one atoms, and then they're ions, right, because they have a charge. All right, hope you guys learned a lot about ions.